Dr. Michael Young of the Bureau of Economic Geology at the University of Texas at Austin delivered the following presentation in Alpine, Texas on January 15, 2020 at the first of a series of seminars engaging the community on energy development in the Big Bend region. Per Dr. Young, the projections cited in the presentation should be considered interim. Video of Dr. Young's presentation is available at the accompanying link. The following has been edited for this format. When it comes to studying the energy development taking place or expected in the Big Bend region, we're really looking at all types of energy systems. Whether it's oil and gas, wind, or solar, all of the different types of energy have some environmental impact. There's no free lunch. The circles on this slide represent the amount of land necessary to produce an energy source used to generate electricity. The larger the bubble, the larger the relative land impact per unit of energy produced. On the lower right of the chart, you can see coal, indicating that it has the smallest footprint of nearly any energy source outside of nuclear. That's because coal has a very high energy density. Solar has a much lower energy density, so more land is required to generate the same amount of power. We're studying the land footprint of all the different energy systems side by side in West Texas to gauge what could happen in the future and how much land will be required. The goal of our research is to determine the likelihood of a particular type of energy source being developed at a particular location over the next several decades. Our approach to doing that is to look at trends and evaluate the overall impact of the particular energy system, be it oil and gas, wind, or solar. We'll start by looking at unconventional oil and gas development, which you may be familiar with as horizontal drilling coupled with hydraulic fracturing into tight rocks or shale rocks. We've been looking at the trends in unconventional drilling over the last 10 years, which is about how long industrial-scale hydraulic fracturing and exploration has been happening. How has that been changing in different parts of the play? A play being a group of oil fields or prospects in the same region that are controlled by the same set of geologic circumstances. While the Tri-County area, including Jeff Davis, Brewster, and Presidio counties, is our current area of interest, we decided we would look at a broader set of 18 counties because given the availability of data, it's relatively straightforward to increase the geographic scope of the analysis. We set out to answer the question, what are we expecting? Looking at the trends, is energy development per square mile increasing or decreasing? How can that inform us about what the future might look like? The trends we see can help inform estimates of future development. We also can integrate data from the Railroad Commission and look at where energy has been produced in the past to help gauge where it is likely to be produced in the future. This map enables us to see the whole region. All of the green dots are existing wells, and the red lines are geologic boundaries of the different basins in the Permian Basin. On the left is the Delaware Basin. That little tongue that sticks out next to Alpine, that's the southwest side of it, and it goes all the way to Balmorhea and into New Mexico. And that's just a geologic boundary that the Bureau of Economic Geology has been studying for decades. You can see where all the wells are located. You can see the dark outline of the Tri-County area, and note that there are very few wells drilled there because the Delaware Basin doesn't really extend into Jeff Davis, Brewster, and Presidio counties. Looking at those wells, we ask ourselves, how much oil and gas are they producing? We can use that as a way of saying if it's increasing, there's more likely to be wells drilled there in the future. The picture on the right shows the city of Pecos. You can see from the key that the darker colors show an increasing trend in energy development. These are areas where we would expect drilling to be located if there's going to be more drilling. The gray colors indicate that production has been low, so we would expect energy companies would be less likely to drill there. Our approach here is to look at how many well pads are going to be constructed. We're not as interested in the number of wells, we're looking at the pads themselves. Each one is about 3.5 acres in size, and they can accommodate multiple wells. So this is known as pad drilling, stack drilling, cube drilling. There are a lot of different terms for it. How many wells per pad are going to be on there? How many pads do we think are going to be constructed in the future? The graph here shows what we anticipate in a medium scenario or business as usual scenario, where we have 3 wells per pad, which is the number of wells per pad where operators seem to be headed. Why 3 per pad? Having too many wells per pad is very, very costly, but one well per pad is also very expensive because the rigs have to be moved around. So 3 is sort of the Goldilocks number of wells per well pad. The chart on the left illustrates the direct impact of well pads on the land. The darker colors indicate more intense development, and the lighter colors indicate less intense development. As you can see, there's very little development in the Tri-County area, just a little bit to the northeast of Alpine. But for the most part, we don't see a lot of oil and gas development in the foreseeable future in the Tri-County area, given current technology. What we're looking at on the right is what we call edge impacts. So from an ecosystem standpoint, or from a habitat standpoint, we add a little bit of a buffer outside of the well pad, and from there we can ask, are there going to be other impacts to vegetation, to habitats, to the kinds of migration areas and pathways that animals are using? The Nature Conservancy and Sul Ross University are doing this work. So together, these two maps give us a sense of how much area we're talking about. If we add all this up across the entire area, that's about 18,000 square kilometers of land, or about 4.5 million acres. If we contrast that with a high development scenario with fewer wells per pad, that number of acres scales to a much larger number. So in dealing with West Texas, one of the things that we are looking at is trying to restore the desert lands that have been disrupted by development. This is extremely difficult to do in a desert because you need water, by definition a very limited resource in the desert of West Texas. Trying to understand where the development could occur allows us to think about what the restoration would look like, so that the land can return to the same activities it's being used for currently, whether that's hunting or ranching, or whether you're just looking for dark skies and open spaces. The goal is mitigating impact on the land and then restoring it to its original state. We were asked by the Stakeholder Advisory Group, are there wells drilled outside of the Delaware Basin? The answer is yes. Quite a few wells actually have been drilled outside of the Delaware Basin, which are represented by the dots on this map. The list on the left is the geologic basin where those wells were drilled. We know the vast majority of those wells came up dry or had very small amounts of production. That tells us there's less likely to be a lot of energy development out here in the future given current technologies. We know the Helios play in northwest Presidio County. That's about a 65,000 acre lease. There is some production out there, but it's difficult to know how extensive that's going to be in the future. The geologists at the Bureau of Economic Geology don't see really large reservoirs that would warrant the kinds of energy development in northwest Presidio County that you're seeing in Reeves and Pecos and all the way up into New Mexico. The Bureau of Economic Geology is doing a lot of work studying water issues in the region. The Bureau runs the TexNet seismological network, monitoring earthquakes to better understand West Texas. Much of that seismic activity is coming from wastewater disposal. What you're looking at here is how much water we expect to be generated as a byproduct of the drilling process. It's about 10 trillion gallons over the next 30 years. It's 1 million acre feet a year to give you a sense of the scale, which is roughly the equivalent of 1.5 Lake Meads over 30 years. Right now, 95% of the water generated is being injected back into the ground through disposal wells. That water is very salty, and desalinating and reusing the water outside of the oil fields has been a challenge. Experts at the Bureau collaborate to look at water, land, and energy production together, providing a much stronger and more comprehensive picture of what's happening out here in West Texas. Getting back to what I said at the beginning of the presentation, the analysis is not focusing solely on oil and gas, but on all energy, and that includes wind and solar. So along with oil and gas projections, we are projecting how many wind turbines might be installed, how many utility-scale solar fields might be installed, how many transmission lines are expected. We have a hard time going too far into the future because these are all governed by ERCOT, the Electric Reliability Council of Texas, which operates the grid for the majority of Texas. And they're really only able to look several years, 2 to 3 years actually in advance, based on when a company comes in with a permit and says, hey, we would like to connect to your power lines, and here's where we would like to connect. Until ERCOT gets those permit applications, their crystal ball is a bit cloudy when it comes to knowing where this is going to occur. But just to give you a sense, this is wind development. So this is as of the end of December of 2019. We're expecting another 4,000 turbines to be installed in Texas over the next 3 years, from the Panhandle all the way south. Very few, if any, would be installed in our Tri-County area that we showed before. This is all information that's publicly available. Our analysis looks at it fairly closely. We work with ERCOT and they work with us. ERCOT is interested in where oil and gas is going to be because they have to install power lines to service the oil field. So they're interested in working with us, and conversely, we would like to talk to them about issues such as this. If we look at solar, we see a big jump in solar generation, all the way up from 3,100 megawatts estimated for this year to 6,000 megawatts in 2022. To give you a sense of how much land that is, it takes about 10 acres to generate a megawatt of electricity. So this is 60,000 acres of land. Some of that is spread out across the state. About 1/3 of that is in West Texas, and a large proportion of that is in Pecos County. So we're looking at this as often as we can to understand where companies are planning to go. We would like to work with the companies to reduce the impact as they install utility-scale solar. The thinking being, once we know what the size is and we know where it's going to be, we can begin to think about how to mitigate any land impacts if it's going to be installed. Nevada has some of the largest solar fields in the nation, 750 megawatt solar fields, for example. And they're generating at that scale while concurrently maintaining the desert ecosystem and keeping the land productive. So there are things that we can do here in Texas and in West Texas with the data we're collecting. As I mentioned before, it's really hard to project where the turbines are going to go, but we can identify areas that are favorable for wind. These tend to be windy areas. I mean, it's no secret, if you really want to put up a wind turbine, it has to be windy. The U.S. Department of Energy publishes these maps that are known as wind energy density maps. The darker the color, the more dense and the more windy the area is, and it would be more favorable for turbines. At the same time, if you're on a really steep slope like a mountain, you can't really install a lot of wind turbines on the side of a mountain. So it has to be relatively flat and windy at the same time. And so we're mapping out these areas where we think it meets those types of criteria. The green dots you see are where the turbines are located already. The gray line here is known as the McCamey-Kress, which is the competitive renewable energy zone. It was essentially legislated into existence by the Texas legislature and is an area where ERCOT is encouraging companies to place their electricity generating facilities so that they can eventually be connected up to power lines. So if you're talking about areas that are really outside of Kress, that requires more permitting and more assessments, and it's more effort for the company. So we see these as being less likely. As you can see, all of the green dots representing wind turbines are inside the Kress. Of course, if you want to have solar, you need sun, but you also need to have relatively flat slopes that face to the south because the sun is coming in and striking from the south. We don't want to have it on really steep slopes, and we don't want to have it too high in elevation. So the green areas here are too high in elevation for solar to be likely here. So lower elevations in the valleys on relatively flat land facing the south, those are areas that are favorable for solar, really large solar farms. These are the several thousand acre type facilities. And you can see where these things are located, basically outside of Fort Stockton and to the south. But in the end, we're really not sure where they're going to be. We sort of have to wait and be reactive a little bit. And through this project, we may be able to help guide them. All this energy development requires pipelines and power lines to get the energy to where it's needed. We have lots of discussions about this, and you can see the power lines, these purple lines. One goes down to Presidio and another is just outside of Alpine. It's hard to imagine installing a power line without expectation of renewable energy being installed. We don't know when, we don't know what, but if there's a power line out there, we expect something's going to be connected to it. And by having this data and working with ERCOT, we may be able to anticipate this in some ways. And that's kind of what the goal is. Of course, you see this huge, dense network of pipelines again. We understand there's 4 or 5 pipeline projects leaving the Permian Basin and heading east and south to Corpus Christi and across the hill country over to Houston. We are looking at this as well. We're trying to get our arms around it as conditions are changing. How are we going to use this data? What's going to be the point of it all? Well, we're looking at a variety of different things that we call land values. These are things that the Stakeholder Advisory Group has helped us to define what's important to you all. Is it dark skies? Is it open spaces? Is it ranching heritage? Is it ecosystems? What are those things that we would then be able to generate maps like this and overlay them over the top of where we expect energy development? We're not trying to say this is where it's going to happen. We're not trying to say this is not where it should happen. We're just trying to provide a look ahead of what could happen. And from that, we can then start having discussions that need to take place with landowners and with companies to avoid areas that might have a higher conservation value or land value, and more carefully place where infrastructure is so that the land values are maintained today and into the future when the oil fields are gone or when the solar installations have been removed.